At this point, I'd like to update you on Fawn Hollow's and Stepney Cafeteria Roof Project. Very important date coming up, October 15th, Town Council meeting, because the bond that the Fawn Hollow project is connected to will be discussed and hopefully acted upon that evening. But we wanted to answer some questions and kind of make sure that everybody is aware of what the two projects are. There are some questions going around town as to, why does this roof cost this much money? And so Jack, Steve Vitello, Gabby put together some work here to get that word out so people understand the nature of the project better. So Jack, if you want to introduce us, and I'll ad lib as we go along.
You got it.
All right.
And as Jim had mentioned,
George.
part of what we'll be doing with this presentation is we will have it up on our website tomorrow too, so that if community members have these questions, they can refer back to this as a resource to hopefully answer those questions. First of all, how was the project bid? How did we arrive at the number? Fawn Hollow is about $1.5 million, and the project was bid through the U.S. Communities Purchasing Alliance. It's basically a consortium of municipalities and agencies across the country, so we have greater group buying power to keep the costs down. Then within the U.S. Communities Alliance, it was rebid. The contractors had to conform to the pricing structure within U.S. Communities, and then 3 contractors bid within that, which lowered the price even more. The last bullet here is another important one for people to understand. In the state of Connecticut, we are required to pay prevailing wage for any project that exceeds $100,000. So when you put those parameters together, there's not a lot of wiggle room for the numbers to come out significantly differently than what we have. Just a very quick review here on Stepney Elementary School. The worst roof here is this blue one, the cafeteria. Just to refresh everybody's memories, that is 100% saturated. The entire surface or the entire insulation of that roof is saturated with water. This is a core cut sample from that roof. We had an engineer up there recently to take another look at a core sample. His statement to Jim, Gabby, and I was that the core sample was so saturated you could wring it out like a sopping sponge. As a result, another thing that we've come to understand about this roof is when you factor in the water load on this roof, the overall weight load for this roof is compromised by 20%. What does that mean? If that means that this roof can handle a snow load of 40 pounds per square foot, if it was fully functioning, you have to reduce that by 20%. So in turn, what that means in a practical sense is when we get heavy snows, this is the first roof we have to get up and shovel, and it puts us in a tricky spot. Especially when all that water up there freezes. That's the thing we want to try to avoid, because once we get into the cold weather, it has to stay that way until it all thaws out again. And we're hopeful that we can get to this replacement for that cafeteria roof prior to the very cold weather, when we're not going to be able to work on it until springtime.
This was actually a very good exercise for us to be engaged in and to really initiate. We had asked for a weight comparison of the wet insulation versus the dry insulation to really try to understand the nature of that and how it affects things. If you remember the past couple of years with some of those terrible storms, the crew, Jack, Gabby, Bill Jarosco, are up on the roofs filling boxes of snow and weighing them to calculate snow loads. And, what we discovered here, of course, is, like Jack said, about a 20% reduction in our snow load capacity because of that water. But it also alerts us to the fact that we have other roofs that have saturation. Remember, we did the thermal scans, and we found sections of the Massac roof, we found sections of Fawn Hollow where saturation is a problem. And so we are putting together a plan for if in the past we were shoveling roofs when we hit 26 pounds, we may want to reconsider now and start shoveling roofs at 15 pounds of snow, just to be more on the safe side. So this is a real serious issue, and I'm glad that we were aware of it and being proactive about getting them fixed.
Here's Fawn Hollow, just to refresh everybody's memories. The original roof is from 1986. The newer additions include roofs from 1989. And what we're looking at with Fawn Hollow is, as you can see, there's patches of wet insulation. The question that we've had from folks in the community is, okay, the roof isn't fully saturated. Why are you taking care of this roof now? The reason why this roof is being taken care of now is that this roof is savable. It can be re-roofed. It's not to the point where it has to be completely torn off. So as a result, we're able to have a cheaper roofing project that will carry the same warranty as a complete tear-off. So we get the same longevity for less money. So it's salvageable. If we let it go longer, it won't be salvageable, and we'll be into a more expensive project.
Jack, if you could go back to the first slide, because the reason for this presentation tonight is to clear up questions, and the question is, why is this roof costing as much money? Go forward to the roof surface of Fawn Hollow, the aerial there. One of the issues that we can't stress enough is the amount of mechanicals. What we call them are roof penetrations. And if you look at this photograph, everything you see projecting upward on that roof is a penetration through the roof, whether it's an HVAC system, a vent system, fans. There's this white line that's traversing the building right here is a gas line that has to be relocated while the roof work is being done. All of these units are substantially sized units. You need a crane or rigging to get them off the roof. When you put the new roof on, you have to adjust their height and build a new, what do they call the pedestal? Build a new pedestal, roof to it, et cetera, so that it's watertight, et cetera. And then you have to have all the riggers go back up and reinstall equipment on that roof. But I thought that you could appreciate the 17 rooftop HVAC units there, plus all of the other roof penetrations. You have a structural mass here. This is the cafeteria. Off to the left side, looking at the front of the building, you have a massive structure back here, which was a solar panel from years and years ago that is no longer functioning. All of that has to be pulled off of the roof and taken down. So that's some of the factors that are involved in this. But Jack, if you would just catch up.
Just as a refresher too, as was mentioned before, the wooden mansard is in disrepair around the entire perimeter of the building, the perimeter of the gymnasium as well. So that's another piece. It's not just a roof within this project. It's the roof, it's mansard, and it's also the soffit, which is the area underneath the mansard. All of that is being replaced.
And let me just point out there that what's happening with that mansard in the condition that it is that water is getting behind that. Okay? So the soffit underneath it, you can see is buckling and stained and that, which means that we're trapping water between there and the building.
And then we won't read this thing in its entirety to you, but it will be for reference on our website. What are the steps to replacing a school roof? What follows are photos that show you a quick pictorial overview of all the pieces that go into this, because it is much more complex than what people see in a residential roof. So first thing that happens, as Jim was mentioning, we have to deal with rigging, we have to deal with cranes to lift up the equipment that's there. As you might recall, we have those 17 units that are defunct on the roof. They have to come off. You have to have a way to do that. Crane time is not cheap. So that's, right from the get-go, there's a pretty significant expense there. We have gravel on top of that whole roof, 69,000 square feet of roof, 69,000 square feet of gravel, tons and tons of gravel. Has to be vacuumed off just like you're seeing it here. Somebody has to go up there and literally vacuum it off into a truck is the way that it comes off the roof. The other thing, all those wet spots, what has to happen is somebody's got to go up there and cut it out down to the decking. That includes insulation areas. Also, these are drains on the roof. With the drain work comes licensed plumbers. They have to go up there for these drains to redo the drains. The roof height will be higher because we're adding insulations. So as a result of adding the insulation, we can't put the drains back the way that they are. They're in disrepair, but in addition, they'll be higher. So a plumber has to go in, add pipe, put new drains on to replace the old. If we find deck issues, this is a steel deck. The deck at Fawn Hollow is Tectum. It's a different material. If we find that the deck has failed, it has to be cut out and replaced. We won't know where we are with that until we get into the project and see the condition after the wet spots have been taken off. We do have a contingency fund built into the projects to take care of that. But if we get into that, as you can see, we're cutting directly into the building when that occurs. So again, that comes with time and cost. Base materials then go on, and one of the things that's been done already, all of this has to be engineered. They have gone up and literally sunk a series of fasteners into our current deck and attached an apparatus to the fasteners and measured the strength of pull required to take the fastener out of our deck. That's for everybody's safety. That's an engineering requirement so that we don't have things coming off later on down the road. Again, you know, this is for the safety and security of everybody in the building. It involves an engineer, and with that comes costs to do that work and conform with the codes to make sure that the project is safe, secure, and something that will last over time.
In the top right corners and the bottom right corners, that looks like flat insulation. It's not. It's tapered insulation. So it's not as simple as just laying, you know, dimensional insulation down on the roof. It has to be tapered to the drains at 1/4 inch per linear foot. So the material is more expensive and it's more complicated to put down than just a straight flat board.
And that slope that Jim's referring to, the 1/4 inch per linear foot, is National Building Code. That's not something we get to choose. That's what's required. Some of these pictures here are of standing seam roofs. We're not going with the standing seam roof, but we are going with standing seam, the same material for the mansard. That's what the material will look like. You might remember the artist rendition in a previous presentation that showed this in reds and greens. That's what it would look like around the mansard of Fawn Hollow once that is replaced. We mentioned the soffit, the area underneath the where the mansard is. All of that will get encased actually in an aluminum material, which will be maintenance free, and we won't have to look at that staining anymore. And again, over time, will save us money because it's not something that we need to be painted. And here we're looking at they're actually embedding the ply material into hot asphalt, and this is where we really get into what we see for the roof. It all gets laid into this hot asphalt. They get the hot asphalt to squirt out, and they cover it in, what's the material, Jim? It's
mineral.
like a mineral, and then also paint it so it has a consistent color and reflectivity so the UV doesn't degrade the materials over time. Once all that's done, the equipment has to be reinstalled onto the roof. We have to deal with the rigging again. We have to have HVAC contractors there. We have to reconnect Freon to air conditioning units. We have to reconnect natural gas to heating units. We have to reconnect plumbing for things like condensate at this point and finish plumbing for drains. So all those contractors have to come back and converge at that point in time as we're nearing the completion of the project. And just some other facts that we put together for you. Fawn Hollow roof is about 69,000 square feet. Average house roof is about 2,000 square feet, just as a point of reference. Much of what we're showing and talking about has to conform with building codes, national, state as well. As mentioned before, the Fawn Hollow roof is being re-roofed. This option is cheaper than a whole tear-off, and we're able to do it right now because the roof is not in such bad condition where it needs to be torn off. It's salvageable. It's cheaper. It's also more energy efficient because we're stacking more insulation on top of existing insulation. So as a result, we're going to have more R value by doing that. So we're really in a sweet spot in terms of being able to make this happen in a cost-effective way. And we'd like to keep it in that spot. If we push it further down the road and we lose that window. The Stepney roof, as mentioned, 100% saturation for the cafeteria. That has to be a complete tear-off. We have no choice. It's beyond any other kind of repair. It has to be completely torn off, and a new roof needs to be put on. As mentioned before, the load capacity is compromised by about 20% right now because of the water load on that roof. And again, we really would like to get that project done before that whole roof freezes into a block of ice. So we're at again, it's an important window of time for us to try and make this all come together.
Attorney Fraccassini is reviewing the contracts. He was working on them today for both projects, and I believe both projects will be before the town council next Tuesday night. Yep. So we're hoping to pull this off. We're hoping to pull the Stepney roof off before Veterans Day, and the Fawn Hollow roof would be probably a late spring project.